solve the last question of this paper, the last MCQ of this paper, by considering the question number 7. Excuse me about this, all this stuff. Okay, so the questions says that, okay, consider we solve this one. So the question says that the equation characterizing the plane the plane tangent to the graph of this function at the point, this point, is, look, to be the easiest way to find, look, basically when you have a function into when you are doing analysis 1 and you had x and y here, you basically have the function f of x equal to y equal to f of x, right? And the graph was like this. Let's say, for example, that this is the point x0, yes or not? And this was your point f of x0. Note that the tangent line at this point was this, is this. Yes or not? What was the equation of this tangent line? It was y equal to, look, y, the explicit variable, equal to f prime of x0 multiplied by x minus x0 plus f of x0. Yes or not? This was the equation of the tangent line. Now we are in analysis 2 in the space. We are no more considering function with one variable but two variables. What does the graph of a two variable function look like? It's something much more it's a kind of yes or not, it's a kind of surface, because now suppose that you take, this is the point with component x0 and y0, right? The tangent planes at this point, there will no more be a tangent line, but there will be what? A tangent, yes or not, to the graph. Is that clear? Now what will be this? Now it's clear that this will be the x-axis, this is the y-axis, and this is the what? The z-axis. Yes or not? At this point, what is this number? This number will be f of x0 yz, and it will be a number. Now you see, as we did here, we will no more say y equal to, it's not going to be y equal to, but it will be what? Z equal to, yes or not? As the function depends on x and y now. Doubts? First of all, you need the derivative computed at this point, right? But now what is the derivative? Is the graph, if the gradient, the gradient of f computed at x0 yz multiply by, pay attention, the gradient is a vector, right? But you should have only a number, you should have only z, it should be an equation only. So when you have a vector and another vector, how do you get them, how do you put them together to get a vector, a number? The dot product. So we do the gradient that is here, the derivative multiplied by, we will do x minus x0, but also y minus, then we will add what? Then we have to have the function at x0, right? Now we ask the function at x0 y. You have done. This is the equation of the tangent plane, very similar to. Is clear? So let's apply it. So function f of xy equal to log of 1 plus x square y square. y4, right? And the point is 2 1, because you can see that the point you need is 2 1. This is just f of 2 1, right? But we know that it means what it means. So the formula will just be z equal to the gradient at the point 2 multiplied by x minus 2, x minus 2, y minus 1, right? It is given. The tangent plane at the point 2 1. The last one is just the image of the point 2 1, f of 2 1. But yes, 3 components, but I will use the last one at the f of, look at the formula, I will use it here. Okay, so I have my x0 and my yz. Is clear? It's clear so far? Then I will just add plus f of 2. Is that clear? It's here. It's just questions. So I need to find the gradient at the point 2 1, right? First of all, let's find the gradient of f. I need to do the derivative with respect to x. I hope you can easily see that the derivative with respect to x is 2x y to power 4 divided by 1 plus x square y to power 4. Okay, the derivative with respect to y is 4x square y cube divided by 1 plus x square y to power 4. The gradient at 2 1 will be, if I put 2 and 1, 4 divided by by 5. Am I right? 2 1 8, no, is it 8 16? This is the gradient, right? And what is f of 2 1? F of 2 1 is log of 3, a log of 5. So the function will be z, the plane will be z equal to 4 5 16 5. Okay, let's say that I can take 16 5 out, so z equal to 4 over 5 out, because this will be 1 and this will be 4, right? Dot product of x minus 1, x minus 2 I mean, and y minus 1 plus log of 3 of 5, right? Okay, give us 4 over 5 multiplied by, this is x minus 2 plus 4y. I'm doing the dot product, right? 4y minus 4 plus log of 5. So you give a 4 over 5 multiplied by x minus x plus 4y minus 6 plus log of 5. Let's see if we have something already like this, or we need to develop more. We probably need to develop more. Developing more will give 4x over 5, right, plus 16x plus 16y over 5. This is 24 over 5 plus log of 5. But do we have it? Isn't it A? Yes, it is A. The answer is A. This one. Okay, so the answer is 7A. Nice. This concludes also this video. Tomorrow we will be doing another paper and so on and so forth. Okay. Yes, but even if there is an exercise, we will perform the exercise in the next section.